Hey, I've had some requests to go over another probability problem or two, so I'm going to be going over this one. I'll share my thought process so you can get an idea of how you can set this problem up, as well as answer some questions about it. So we're looking at a problem here where it says, suppose a computer company has manufacturing plants in 3 states. 50% of the computers are manufactured in California. So you know, I'm going to highlight some stuff here. And then 85% of these are desktops. Okay, so I'm going to highlight this a different color because actually, you know what? I'm going to keep it the same color. I'll tell you why in a second. So I'm dealing exclusively with California. I'm going to keep them the same color. So it's 30% of computers are made in Washington and 40% are laptops. Okay. And then I'm learning about Oregon here, which I'm going to highlight in blue. Oregon, 20% of computers are manufactured there, and 40% of these are desktops. Says all computers are shipped to a distribution site before sending out to stores. So before I even address this question, I want to start calculating some probabilities, and then I can address my question. Now, it looks like I've got some conditions set here. So I'm starting with California, and within California, I know 85% of those laptops from California are desktops. Since I'm dealing with conditional probabilities here, I'm going to be using a tree diagram. Now, you have a number of ways you can do this. This is the way I'm opting to solve this problem. So I'm going to set up first where these computers are from. That's the first thing that we're looking at here. So I know that 50% of my computers are from California. 30% are from Washington. So I'm going to go with 0.3 are from Washington. And then the rest, the 20%, are going to be from Oregon. Now, just to check, I'd probably do 0.5 plus 0.3 plus 0.2. Gives me 1, so I know I'm covering 100% of my computers. Now, based on what I'm looking at here, now I'm having computers that are either desktops or laptops. I'm starting in California. It's telling me that 85% are desktops. So I'm going to California here. 85% or 0.85 are desktops, which means the remaining laptops are going to be 0.15. I could do this using the complement rule, just doing 1 minus 0.85, and that'll give me that 0.15. That's where that came from. Please excuse the noise outside. So I'm going to do the same thing here for Washington as well. So if I look at Washington, 40% of these laptops from Washington are 40% of these computers from Washington are laptops. So I'll go with 0.4 for laptops, which means using the complement rule, 1 minus 0.4, I can figure out that the remaining 60% are desktops. And then I'm going here to Oregon, where 40% are desktops. And the rest are going to be laptops, 60%. I probably wanted to keep them the same order. You know, so when desktops, desktops, really doesn't matter. But now what I'm going to do is I'm going to multiply these out just so I have them. And, you know, I might need them for my question, but it's always a good idea to get some practice with notation as well as some of these rules here. So I can use the multiplication rule of finding out the probability of, probability of A times probability of B given A are going to give me the probability of A and B here. So let's do this out. 0.5 times 0.85. I'm going to do this on a separate calculator here. I know I sometimes do it on my laptop, but just to save me some screen sharing, 0.425. So probability of getting a computer from California that is a desktop is 0.425. Probability of getting a laptop from California is 0.075. Now, just to check, I can just add these up, 0.425 plus 0.075. I get 50%, which explains that 50% from California. So I'm doing something right here. We'll continue going here. Probability of getting a computer from Washington, that's a laptop. 0.3 times 0.4 would give me 0.12. 0.3 times 0.6 to give me probability of getting a desktop from Washington, give me 0.18. And I'm doing probability of coming from Oregon and being a desktop. It's going to be 0.2 times 0.4, 0.08. And then last but not least, probability being from Oregon and a laptop is going to give me 0.12. So again, all I did was I multiplied out each branch here. I did that each time, just multiply them out. Exactly what I did. So that's where you would go to get here. Now, if I want to find the probability of everything, right? My entire sample space, I can just add all these up. So if I add all these up, if I did everything right, I should be getting an answer of 1. So I'm going to do it out quick. I do. I got a probability of 1. So I did everything right. So now they have all these probabilities. I can start dealing with my question here. It says all computers are first shipped to a distribution site. If I picked a computer at random from Nebraska at the Nebraska Distribution Center, what's the probability it's a laptop? So I'm going to go through all these and look for my laptops. I got probability being from California being a laptop, probability being from Washington being a laptop, probability of being from Oregon and being a laptop. So you notice I have 3 probabilities here. I'm just going to add these up. If I add them up, I'm going to get 0.315 or 31.5%. That would answer my question here, but I'm not done. I want to go a little bit further with this. Say probability that given that I'm getting a laptop, what's the probability it's coming from, let's say, California? Because I was curious because I saw that number a bit lower than what I expected. So I'm going to write it out as the probability it comes from California, given that it's a laptop. Notice I'm using my notation here. That's good. Now, when you're dealing with a given situation, you're thinking like, what's that whole subgroup here? The subgroup I'm dealing with here are laptops. So I already found the probability of getting a laptop out of this bunch. It's going to be 0.315. And all I did was to add up all my probabilities that had to do with laptops. Now, within this subgroup, what's the probability that they're from California? I'd look here. Oh, I have probability of California being a laptop is 0.075. So again, to get there, this is what I did. I did the probability of being a laptop over the probability of being a laptop and from California. Or I could do California being a laptop. When I divide that out, let's see, I'll figure out what it is. Why not? I mean, you can leave them as fractions. No one said you can't do that. Sometimes it's good to have these. Okay, so I get about 0.23, about 24%. So say I wanted to go in another direction with this. Say I wanted to go the opposite way. Given that laptops from California, what's the probability? I mean, given that computer, is from California, what's the probability that it's a laptop? All right. So now, so my given California, I'm going to look at all my California computers, which I know from the beginning of the problem is 50%. 50% of them come from California. But if I really wanted to, I could just double check and maybe I'll just add all my branches here that have to do with California. Here we go. 0.425, 0.075. I'm going to get 0.5, just what I expected, about 50%. Out of that 50%, how much are laptops? Let's take a look. 0.075. Okay. So what I did was I set up the probability of being from California. And then on top here, I did the probability of being from California and being a laptop. So if I divide this out, probably going to get something a lot lower than what I was expecting. 0.075 divided by 0.5. Yeah, about 15%. That's pretty low. So as you can see, this is one way where you can calculate probabilities based on conditional probabilities. Like in this case, our condition was, all right, we had laptops that were from California, Washington, or Oregon, and they were giving conditional probabilities. Like if it's from California, 85% of the California computers are desktops. 15% of the California computers are laptops. That's a conditional probability. It's based on, we know that's from California. Same thing with Washington here. If 30% are from Washington, within that 30%, 40% are laptops, 60% of those are desktops. So I'm able to figure out within my total sample space what percentage are from Washington and laptops and what percent are Washington and desktops. Hopefully this helps you a little bit, at least as far as setting it up, being able to work with it, because tree diagrams can be really helpful when you're dealing with conditional probabilities, and as well as the sequence of events. Like in this case, a computer comes from California, and then either it's a desktop or a laptop. It could come from Washington, and then either it's a laptop or a desktop. Nice sequence of events there. So tree diagrams can be really helpful with that. Hopefully this helps you a little bit. And again, if you have any questions, always feel free to reach out to me at gamashstats@gmail.com. Or wait, it's statsgamash. Whoops, there you go. statsgamash@gmail.com. All right.